All right, 3.4, solve systems of linear equations in 3 variables. So the problems that we've been doing are 2 equations, 2 unknowns. Now we have 3 equations, 3 unknowns. And so the first problems are going to give you a ordered triple, and you're going to take those values and plug them in for x, y, and z and see if it works. So we're given the point -1, -2, 5, and the equations 4x minus y plus 3z equals 13, x plus y plus z equals 2, and x plus 3y minus 2z equals -17. So if at any point it doesn't work or it's not equal or whatever, then we can automatically say, no, it doesn't work, it's not a solution. But if you get one that is a solution, you need to at least check one more to make sure that it wasn't just like a solution to the one and not the others. So I'm going to pick the easier one, so the one in the middle. So -1 minus 2 plus 5 equals 2. -3 plus 5 is 2, so 2 equals 2, so that one works.
Wait, where'd you get 3 from? Is that not a 3 or not a 1?
What are you talking about?
4x minus y plus 3z equals 3.
That's the equation.
Yeah, but...
What do you mean, where did I get it from? It's from the book.
Oh, I'm smart. Never mind.
And then I'm going to do another one. So x, so -1 plus 3 times -2 minus 2 times 5 equals -17. So then -1 minus 6 minus 10 equals -17. So -17 equals -17. So since I got 2 that work, I can say that this is a solution. Let's see, number 6. -5, 1, 0. And the equations are 3x plus 4y minus 2z equals -11. 2x plus y minus z equals 11. And x plus 4y plus 3z equals -1. So top one, 3 times -5 plus 4 times 1 minus 2 times 0 equals -11. So -15 plus 4 is -11 equals -11. So that one worked. And check one more. 2 times -5 plus 1 minus 0 equals 11. So -10 plus 1 is -9 equals 11. That one doesn't work, so it is not a solution. Alright, so that stuff, not so bad. Now we're going to actually solve the equations. And I'll tell you, normally on a quiz or a test, you're only going to get one of these problems just because they take like super long time to do. Well, they can take a super long time. So, And they say, like, they specify a method that you need to use. So if they specify, you do need to use whatever method they say. Otherwise, you can just pick whichever one you would prefer. So 10 says to use elimination. So 2x minus y plus 2z equals -7. Negative x plus 2y minus 4z equals 5. And x plus 4y minus 6z is equal to -1. So just like with the other ones, we're trying to figure out what variable can cancel. And basically, I'm trying to get a canceled equation from two of the equations that we already have. So I'm going to use initially the bottom two because negative x and positive x, those things already cancel, so that works out nicely. And whatever variable you cancel for the first one, you also have to cancel for the second one. Okay, so when I cancel these x's, I get left with 2y minus 4z is equal to 5, and 4y minus 6z is equal to -1. Oh wait, pause. I need to actually add them together. Back up. Go ahead and add them. You can rewrite them if you want, but just go ahead and add them. Just the two. Sorry, yeah, just the two. We canceled the x's, and I was just going to rewrite them and then combine them, but we don't need to do that. Just combine them right away. So 6y minus 10z is equal to 4. There we go. Just save a step. And then now we need to cancel the x's again, but I need to do it in different equations. So I can do, I've already done the bottom two, so I could do top and bottom or middle and top. And so I'm going to go ahead and do middle and top because they have opposite signs. So I need to multiply this bottom equation all the way across by 2. Which is then going to cancel. So usually if I end up having to multiply an equation by something, I will rewrite them just to avoid having a problem. So 2x minus y plus 2z is equal to -7. And then multiplying this one by 2, I get -2x plus 4y minus 8z is equal to 10. So 3y minus 6z is equal to 3. And so now that's what I'm putting over here. So now I have two equations and two unknowns. Make this a little clearer. And so now once I'm at this point, I'm back to what I was doing in, what was it, section 2. So what do I need to multiply one of them by to cancel something? Which one? So I'm going to have 6y minus 10z is equal to 4. And I need a -2 here. So that's going to be -6y plus 12z is equal to -6. So 2z is equal to -2. So z is equal to -1. So all that work to solve for one of the variables. Now, I'm going to take this number and plug it into one of these two equations that I had up here and solve for y. So which one do you want to do, top or bottom?
Top.
So 6y minus 10 times -1 is equal to 4. So that's going to be a positive 10, so I'm going to move it over. So 6y is equal to -6. So y is equal to -1. And then now we can take these two numbers and plug them into one of the originals up here. So I'm going to do the one that already has x like by itself. So x plus 4 times -1 minus 6 times -1 equals -1. So that's negative 4 plus 6 is going to be 2. So subtract 2. So x is equal to negative 3. And then always write your answer as an ordered triple. So negative 3, negative 1, negative 1. And you solved it. And you can plug it back in and do it like we did in problem, whatever it was, 4 and 6 that we did, to check and make sure that you did it right. This is probably the section that it's more critical that you check them even more so than the other section that we did, because obviously there's a lot more work that goes into it. Let's see. Number 12. Four x minus y plus 2z is equal to negative 18. Negative x plus 2y plus z is equal to 11. 3x plus 3y minus 4z is equal to 44. All right, so which variable do y'all want to cancel in this one? Really doesn't matter. You can take your pick. Or and which two equations are you wanting me to start with?
The bottom and the middle.
Okay, so what am I... There's nothing I can immediately cancel, so what do you want me to do?
Multiply the top by 3.
Multiply the top by 3, so I'm going to cancel x. So I'm going to have negative 3x plus 6y plus 3z is equal to 11. And so since these are already right here together, I'm just going to combine them without having to rewrite them. So I'm going to do this. Yeah.
Could you multiply both equations by, like if we did the top and the middle and did it by negative 2, could you do that? Just by just doing both equations for like no reason? Could you just,
Like to like get y by, like to solve for y instead? Or to like cancel y? Yeah, you can. I just try to pick whichever one is the easiest one. But if you were going to do, I mean, you could do the y's here and then obviously do this is a negative y, so then multiply that one and do like a canceling earlier, easier. Yeah, it's really up to you. There's sometimes that one is like way more difficult to solve for than the others, but it doesn't matter. This one, it really wouldn't change anything.
Equals 33.
Yes, thank you. I was just looking at that. Yeah. So then this new equation here, the 3x's cancel, so I'm left with 9y minus z is equal to 77. And so then I need another equation. So then which other ones do you want to use now? And tell me what to multiply it by, if it needs to be.
Top, bottom, top. Not bottom, top. Bottom, top and middle.
Top and middle. Yeah, you can do top and bottom, but it's going to be a lot more work. And what am I multiplying by?
Middle times negative 2.
To cancel x?
I was canceling C.
You can't do that.
Oh.
You got to cancel the same thing out of both.
Then 4.
So multiply the middle one by 4. So I'm going to rewrite them over here. So then this is negative 4x plus 8y plus 4z equals 44. So that's 7y plus 6z is equal to, is that 26? I think.
How come you can't solve for x? Or not x, z?
Because you told me you wanted to do x.
Oh.
So now I'm putting those two together. So nothing immediately cancels, so what do I need to do now?
Multiply the top by 6.
Oh, that's so annoying.
There you go.
Multiply the top by 6. So then that's going to give me, what's that, 54y minus 6z is equal to, I'm just going to have to do that over here. 462, I think. Gotta check that and make sure something just fell. Nope, not minus. Yeah. So then that 61y is equal to 488. So y is equal to 8. At least it didn't end up being that bad. So now, do you want to plug this y equals 8 into the top or the bottom one of these?
Like, is it the original equation?
I would do the original because I really don't want to plug it into 54 times that and it's equal to 462. I'd rather plug it in there if I was going to do that one.
I do the
Just do the red one.
Yeah, I would say do the red one. 7 times 8 plus 6z is equal to 26. So that's 56 plus 6z is equal to 26. Subtract 56. 6z is equal to negative 30. So z is equal to negative 5. And then equation 1, 2, or 3 to plug them into to find x. Middle, so negative x plus 2 times 8 minus 5 equals 11. So 16 minus 5 is 11. 11 minus 11 is 0, so x is equal to 0. So 0, 8, negative 5, yep.
I would check these.
I just plugging in 0, 8, negative 5.
That's a lot of math.
All right, how do we feel about the elimination method?
Good.
Okay. All right. I'm gonna do 1 by substitution just so that you can see it. But honestly, I normally just use the elimination method because I think it's easier. But 16. And also just another thing to note, you can still have no solution or infinitely many solutions with this as well. So that can happen. But 16, these ones say substitution. So 2x minus y minus z equals 15. 4x plus 5y plus 2z equals 10. And negative x minus 4y plus 3z equals negative 20. So I think I am going to get z by itself in the top one. Doesn't really matter, just trying to do something different. So negative z is equal to negative 2x plus y plus 15. So z is equal to 2x minus y minus 15. So I'm going to plug it in to,
That's weird.
yeah, I don't really ever use the substitution method because I think elimination's easier, but I'll do like to try to show it at least once, but negative x minus 4y plus 3 times 2x minus y minus 15 equals negative 20. Because we're basically going to end up doing substitution twice and then elimination from there. So then negative x minus 4y plus 6x minus 3y minus 45 is equal to negative 20. So then 5x minus 7y is equal to 25. So then this is one equation that we're working with. And then I would plug it into, what did I just do, the bottom one? Plug it into the middle one also. So then 4x plus 5y plus 2 times 2x minus y minus 15 equals 10. And then 4x plus 5y plus 4x minus 2y minus 30 equals 10. 8x plus 3y equals 20. So then there's the other equation, which is fine, but it just gets to be a lot. Like, this is way more work than the elimination method. So I'm just going to let you use elimination when you have to do them. But this way you know how to do substitution. So then from there, just to save having to write it a whole bunch of times, what am I going to be canceling and what do I need to do to be able to do that? Just pick the lesser of two evils.
Multiply y. Multiply the bottom one by 7 and the top one by 3.
Yep. So the top one is going to give me 15x minus 21y is equal to 75. And then the bottom one, 56x plus 21y is equal to 140. So 71x is equal to 215. Did I add that right? Something's wrong.
What?
That was awful.
Something's wrong because that's not the right answer. Because that's a decimal. I don't know what's going on. That's not the right answer, though. Something is wrong. Do y'all see somewhere where I have something written wrong? No.
I didn't know.
Well, I'm just like, make sure I didn't like add something wrong or whatever, because I was like moving stuff around and.
There's a lot to look at.
Yeah, that's why I'm like trying to go back. I'm like, it's gonna take me longer to figure it out then. Anyways, we'll just say that for right now, that's how you do substitution, like by plugging stuff in, but it is way more complicated, to be honest, so just use elimination.
Like the 7 times 20.
56 plus
Wait, no, it
2.
isn't.
6x minus 2y minus 30. 6x minus 3y minus 45. Add that
Oh,
over.
I see it.
Where?
It should be plus 30, it should be 40. On the 4x plus 5y.
Ah, yep, that'll do it. Thanks. All right, so then, hold on. So then 7 times 40 is 280, right? Let's see. Yeah, okay. So then now, plus 75. So this is 355 divided by 71. There we go. So that's 5. You shouldn't get a weird decimal answer, which is what told me something was wrong, because it was like 3.087652, and I was like, that's definitely not it. You should be getting whole numbers. I don't think any of them give you a fraction or, yeah, they don't. So then at this point, pick one of the two originals to plug it into. So 5 times 5, so that's just 25. Minus 7y equals 25. So y is going to be equal to 0. And then take these two and plug them into this z equation. So 2x, so 2 times 5 minus 0 minus 15. Which is negative 5. So then my ordered triple is 5, 0, negative 5. Yeah. All right, one more thing just so you can see something. It's not going to be an entire problem. I just need you to see something about it. 18x plus 3y minus z equals 12. 2x plus 4y minus 2z is equal to 6. And negative x minus 2y plus z is equal to negative 6. So initially, I look at this and I have a positive z and a negative z, and I also have a negative x and a positive x in the top and the bottom one. And so I'm going to use that one to cancel first. So I'm going to do those two, and so that's going to give me y is equal to 6. And then I'm going to use opposite signs. So I'm going to use the middle and the bottom. Multiply the bottom one by 2. So I'm going to have 2x plus 4y minus 2z is equal to 6. And then I'm going to have negative 2x minus 4y plus 2z is equal to negative 12. And so what happens? 0 on this side, negative 6 over here, which means what? No solution. And so then we would be done with that. So that's why you can still have no solution. Infinitely many, it's all possible. Very, very rare that happens with 3 equations and 3 unknowns just because of the nature of them. All right, so your problems 5, 7, which are just the checking ones, and then 9 and 19. I would just personally use elimination for both of them, even though one technically says to use substitution, unless you just for some reason really liked the substitution method, but I think it's way harder, so I wouldn't.